Hi, welcome to my video on maximum word problem on level 2. This is the first word problem on maximum. But before I start the word problem, I want to apologize for the error that I made in the previous video, and that is finding the derivative of a variable, the previous video, on page 3 of 4, number 7D. And I had area equals length times width, and then I substituted the width in. A equals L times 1/3 L plus 3, and multiply L by this binomial here, and you get 1/3 L squared plus 3L. And the error that I had a minus 3 there instead of a 1/3. So when I did the derivative here, I had a negative 6L plus 3. So that's wrong. The derivative should be, when you do the derivative of dl, I should get 2 times negative 1/3 is negative 2/3 L, and the derivative of 3L is 3. So instead of having a negative 6 here, it should have been negative 2/3. Apologize for that error, but I noticed it after I looked the video over. Now let's do a maximum word problem, and I say level 2 because these are a little bit more difficult and you need some calculus to handle these. The lower side of a rectangle is on the x-axis and the upper two vertices are on the parabola, and the parabola is y equals negative x squared plus 27. Find the maximum area of the rectangle enclosed in the parabola. So what we have an x-axis, and we have the y-axis, and the lower side of the parabola is on the x-axis, the lower side of the rectangle is on the x-axis, and the two upper sides on the parabola. So let's look at the parabola y equals negative x squared plus 27. So in this parabola, if you let x equal 0, you have negative 27, so that gives you x is 0, 27. So let's pretend that that's right there, so that's a 0, 27. And the parabola is negative, so it's opening downward. And notice that there's no x there, so that means that if you do the derivative, if you wish, or if you do y prime on this, you get a negative 2x, and that's a 0, so you get a negative 2x equals 0 if you let your y derivative equal to 0, and that means the x coordinate, the vertex, is 0. So if the x is 0, that means, which we already established, the fact that it's 0, 27. So the parabola is opening downward like this from that point. So it says the lower side of the parabola is on the lower side of the rectangle is on the x-axis. So the lower side of the rectangle is on the x-axis. That's here. And the other two vertices lie on the parabola. So we take this point here and this point here and drop a perpendicular down and drop a perpendicular down to the x-axis. Then this is the part of the rectangle that lies on the x-axis, so this is parallel to this, and these are all right angles, so this is a rectangle. So whatever this point is here, this is the point x comma y, but we know that y is negative x squared plus 27. Also over here we could have, this is negative x, and this is, the y value is the same. So these are the coordinates of this is the coordinates of the point that lie on this parabola here and here. Now, if this is x and that's negative x, then this distance from here to here, so that's x, that's a negative x, but let's keep it positive. So that means that this distance through here is a 2x. So that's 2x from there to there. Makes no difference if it's positive or negative. The distance is 2x. The length or the width could be 2x. And if this is the y value, this is the distance up. So this value here is negative x squared plus 27. Because that's the distance up from the x-axis to here, so that's the y value, which is here. So that's the length and the width, but which is which? Well, if you put 2 in here, you get a 4. If you put 2 in here, you get 4. 27 minus 4 is 23. So this is the length and this is the width. So the area of the parabola, I keep saying parabola, the area of the rectangle, length times width. So the area is, the length is 2x, and, or the width is either or, whatever way you want to say it. So it don't make any difference if you write it down as negative x times 27 times 2x, or you write it down like this. It makes no difference. Anyway, if this is the length and this is the width, then you could write it like this, or you could write it like this. So the area, multiply that, is a negative 2x cubed plus 54x. And so to find, it says they want to find the maximum area of the parabola enclosed. I didn't finish reading it. Find the maximum area of the rectangle enclosed in the parabola. So we want to find the maximum area here. So the maximum area is maximum is related to doing the derivative, the instantaneous velocity at some value of x. So let's do the derivative, and the derivative here is negative 6x squared plus 54. So if we make the derivative equal to 0, so we'll find the value of x where the maximum is going to occur, and so we make negative 6x squared plus 54 equal to 0. So negative 6x equals negative 54. Divide by negative 6 and you'll get a 9. X is equal to plus or minus the square root of 9, so x is equal to plus or minus 3. The value of x is, right here, is 3. Okay, so let's take the 3, or we could take the negative 3. Let's take the 3. So the area is defined as negative 3, negative 2. There's the area. Now, there's the derivative here. The area is negative 2x cubed plus 54x. So if I sub the 3 in here and cube it, here we go. So I sub the 3 in. That's 27 times negative 2, so that's a negative 54. And this is 54 times 3, which is 162. And when you add that up, you get 108. And the area, it didn't say that what unit it was in, so that's square units. So the maximum area is 108 square units. Again, we have a rectangle inscribed inside. We would say inscribed, but it's inside of the rectangle. And one side is along the x-axis, the other two vertices are on the parabola. And by letting y equal negative x squared plus 27 and working it through, doing the derivative, you found the maximum area to be 108. That's one problem on maximum area. And again, if you like the video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.